Hey, so in this video, I'm going to go over the solution to the first exam in the Economics of Entrepreneurship class. All right, so suppose you've got a business now selling masks, but have a reasonably high market power based on your particular design. So you survey your customers to build a demand curve, estimate the demand elasticity to be -5. We're pretty confident we can trust that value. Your current best-selling mask is priced at $10. You have a marginal cost of $6. How should you change your price? So what we're going to do is we're going to think about so this is everybody answered the same questions, but possibly in different order. So this might not have been your first question. Anyway, so we're going to use our percentage markup, like our, this is going to be our link between like profit maximization and elasticity from the lecture slides. And so we've got this relationship, percentage markup, right? Markup is price minus marginal cost divided by price makes it percentage markup. And then here's 1 over the price elasticity of demand. All right, so what I'm going to do is I'm going to put in the marginal cost of 6, put in my price elasticity demand of 5. And so what we end up having is one unknown, which is price, which we're just going to go ahead and solve for. So 5 times the quantity, price minus 6, equals price times 1. And then 5p minus 30 is p. Move this p to the other side, that's 4p, and then over here move the 30 to that side, that's 30. 30 divided by 4 is 750. So this is telling us the current price is 750, but for this elasticity, the optimal price is the current price is $10, but for this price elasticity, the optimal price is 750, so we should lower the price per mask to $7.50. All right, so in a perfect world, you'd want advertising to both shift your demand curve outward and make your rival's demand curve more elastic. And so that's this right here. This stupid thing is covering over inwards and inelastic as option A. That's not the right answer. The right answer is option D. You want advertising to shift your demand curve outward. You'd rather have demand 2, right? Think about the horizontal intercept. That's like the size of the market, the number you could maximally sell or give away for free. You want that as large as possible. You also want yours as steep as possible. But if yours is becoming steep, that's because there's comparatively fewer substitutes in the minds of consumers, which must mean, which is good for you. Now, what about for the standpoint of your rival? Oh, you want your rival's demand curve to be pretty elastic because you want, especially yourself, to be a good substitute for your rival. So kind of reversing that logic. I want to just jump in with a revision from what I'd had on the sheet here. The strategy of limit pricing can make your opponents believe that your demand is weaker than it actually is and your costs are lower than they actually are. You want them to think that the demand environment isn't very favorable, and you want them to think that you have a greater capacity to cut prices. So you want to think of limit pricing like restrained pricing under the threat of entry, and you have greater capacity to extract monopoly profits if you're not worrying about entry. So again, we're trying to make the rivals think that the demand situation is pretty unfavorable and that the competitive situation is going to be not very favorable because you're going to be able to, you have a greater capacity to cut price than maybe you actually do. Consider a location model. Suppose each firm chooses taste parameter X to correspond to its position on the unit interval. For example, the highest level of the taste parameter is 1 and the lowest is 0. The center is 1/2. Suppose there's 2 firms. If there's fierce price competition, where should they locate? Well, how do we get away from perfect competition? Product differentiation. So you'd want to differentiate as much as possible, locate at the ends, right? One locates at 0, the other locates at 1. This is our principle of maximal differentiation. Suppose you have 200 people to determine, and you interview 200 people to determine their response to your new product. You offer a price of 40 and a price of 35. 15 buy at the price of 40, 35 at the price of 35, 25 buy. So then what's our demand? Okay, so we've got these 2 points. This is just the slope formula from like, I don't know, middle school, high school algebra or whatever. So this is the slope of -1/2. And then here's our point slope formula, same class or whatever. So y minus y1 equals m times x minus x1. Just evaluating at the point we've got, 40 and then 15. And then just algebra to solve, we find, oh, and then at a certain point, I switched my x for my q and my y for my p. And then, yeah, the demand curve is 95 minus 2p. All right, so your production manager tells you the marginal cost is $10 per unit. Marketing manager says the demand curve is 80 minus 2p. No competitors. What price do you set? This is single price monopoly pricing. So let's take my demand curve. Let's generate my inverse demand curve. It's a little bit easier to work with. Wouldn't have had to have done that, but that's how I want to do it. So I'm going to move this to the other side. 2p equals 80 minus q. Divide through by 2. 40 minus 1/2 q. You could do this with calculus, but I'm remembering that to get from demand to marginal revenue, it's the same vertical intercept, but twice the slope. So I'm just going to double my slope. That's Q. So MR is equal to 40 minus Q is equal to 10. I've got a video on that if you kind of forget those details, but let's just kind of solve this one here and move on. So Q is equal to 30. And then, because I'm hearing a lot of noise upstairs in my house, and so I want to go I know what that is. All right. Prices, and then we found the quantity, and then we'll evaluate my inverse demand at that price, and price of 30 is going to be 40 minus 15. Oh, it's 25. Yep. All right, so here you and your competitor are choosing whether to enter a new market. There's no sunk cost of entry. Suppose if both firms enter, you compete and you make profits of 30. If only you enter, you make a profit of 120 and your competitor makes a profit of 0. If only your competitor enters, they make a profit of 120, you make a profit of 0. If no one enters, you both make profits of 0. All right, so here's my game tree. This covers up stuff that we actually kind of don't need here, so don't worry about that. Here's the game tree. You enter or you don't enter. They enter or they don't enter. They enter or they don't enter. This is where they enter after you've entered. This is where they enter after you have not entered. Payoffs are 30-30 if you both enter, 120 to the person or to the firm that enters, and 0 to the one that doesn't, right? Okay, your payoffs are the first one, their payoffs are the second one. All right, so the way that we solve is by backward induction. We go to the end of the game and we say, okay, if I'm choosing right here, I'm looking at the payoff of 30 or 0 if I'm choosing here. 30 is higher than 0, so I will enter. If I'm choosing down here, I'm looking at the payoff 120 versus 0. 120 is higher than 0, so I will enter. Now we fold back in the game and we go to the beginning, and this player is going to look forward and say, oh, there's no reason to even think about this one or this one because we know this is what's going to happen. If we enter, they're going to enter, and our payoff will be 30. If we don't enter, they're going to enter, and our payoff are 0. We'd rather have 30 than 0, so we enter. So the Nash equilibrium, the subgame perfect Nash equilibrium, the backward induction equilibrium is they both enter, and the profits are 30 each. All right, so suppose you produce two products. They could potentially be sold together. You have two different types of consumers with these reservation prices, actually three different types of consumers with these reservation prices. What single price should you charge for the price of good 2? All right, so I meant for this to be price of good Y, and the optimal price is 60. If you sell at a price of 60, you are going to end up having, let's see, marginal costs are 0, so you're just maximizing revenue. 60 times 3 is 180, and then 80 times 2 is 160. Okay, so you don't want to just set the price of 80 and sell to both, and you don't want the 120 selling to just one. You want to sell to all three, so you set the price of 30. Or sorry, set the price of 60 and then sell to all three, and your revenues and profits will be 180. All right, so the answer was 60. Suppose the marginal cost to produce your product is $4 per unit. Your price elasticity is minus 2.5. Product has an advertising elasticity of demand equal to 0.5. What's the optimal advertising elasticity or ratio of advertising to sales? A over revenue, right? So here's our formula from lecture. So your advertising elasticity divided by price elasticity of demand. Here I've used eta to distinguish between advertising elasticity. And then here's our ratio of advertising to sales. Okay, so we had a 0.5 here, we had a 2.5 here. 0.5 divided by 2.5 is 0.2. Right? So that was the answer. Suppose you produce two products, potentially could be sold together. You have two different types of consumers with these reservation prices. What price should you sell the bundle of product X and product Y? Well, it turns out you want to ignore consumers B and C because consumer A has this massive willingness to pay for product X. Remember, for bundling to be a good idea, you have to have negatively correlated preferences and then fairly similar demands. These are not similar demands because consumer type A has just much larger demand for product X. So you can see this by looking at the bundles though. 800 plus 60 is 860. 120 plus 80 is 200. So I could sell 200 to all three and get 600, or I could just sell the bundle of 860 to type A and get 860. All right, so we're going to ignore consumer B and C. All right, so that was the multiple choice component. And then what about, here's our puppy study break. So here's the puppy. Puppy's all grown up now. All right, so here was the longer form questions. So we have a two-part tariff. So we have the market represented by 90 minus 3p and then 180 minus 6p. I noticed I made a mistake and I put in 30 minus 3p instead of 90 minus 3p. And I made an announcement and said that I'd kind of grade it both ways. I didn't catch a whole lot of people that did this. I think virtually everybody just used these demands, which is what I was looking for. But if you did it the other way, I was just looking to see, did you use kind of Econ 490 methods to solve the two-part tariff? Okay, so find the optimal two-part tariff scheme if you're required to charge a per unit price of $10, but have to offer the same fixed price to both types. Find the optimal two-part tariff scheme if you're free to set any per unit price, but must offer the same fixed price to both types of demanders. And then find the optimal two-part tariff scheme if you're able to offer a different fixed price to both types. All right, so here's how we think about this. If we have to offer the same fixed price, now we have to think carefully about what's the fee that we're going to set, because we have to determine, do we want to sell to both groups or just to one? Right? I gave us the price of 10, which is requiring us to set price equal to marginal cost. So we're just going to find the consumer surplus associated with that price and then see which is better, to sell the same to both or just one for the higher. Here, if we're free to set any per unit price but have to offer the same fixed price to both types of demanders, this is where we want to write up profits as a function of price and then solve for the optimal price. So I'll show that. And then find the optimal two-part tariff scheme if you're able to offer a different fixed price to both types of demanders. So here, basically, you can offer them their own access fee. So actually, once you've done part A, part C should be really easy, because you'll just find out what's the consumer surplus for this demand, what's the consumer surplus for this demand, each at marginal cost of 10. And then that's the fixed fee for each group with the price of 10. And that's just for part C. Okay, so here I've got the answer, but let me go and do this carefully. So here is our first demand, 90 minus 3p. Here's the second demand, 180 minus 6p. If I change this around to get my inverse demand, right, move the 3p to the other side, 90 minus q, divide 3 by 3, price is equal to 30 minus 1/3 q. That's going to be this, right? And then over here, solving, I get price is equal to 30 minus 1/6 q. I put in the marginal cost of 10, and the optimal fixed fee when I charge a price of 10 in this group is going to be this consumer surplus here. And then when I charge a price of 10 in this group, it's going to be this consumer surplus here. To do that, we have to find out how much are they going to buy at the price of 10 in each demand. All right, so that's what this is. Q of 10 is going to be 60 for this demand curve. So my consumer surplus is going to be 1/2 30 minus 10. That's just from the price minus marginal cost, 30 minus 10. And then this length right here is the 60 that I found down here. So 30 minus 10 is 20 times 60 times 1/2 is going to be 600. Oh, but we got to multiply that by 5 because we've got 5 consumers of that type. So that's a total of 3,000. And then what about over here? It's going to be 1/2 30 minus 10 for the same reason. It's just 30 minus 10 is the vertical height. Remember, the area of the triangle is 1/2 base times height. That's our consumer surplus, the area under the curve. This is a 120 because 180 minus 60 is 120. Okay, that's this right here. And so that gives us 1,200, but we've got 5 such consumers, so that's 600 or 6,000. There's 5 consumers of each type. We have the choice to make. We could either set the tariff of 600 and sell to all 10. That's going to give us 6,000. Or we could set the tariff of 1,200 and sell to just 5. That's also 6,000. So my profits for part A is going to be 6,000 either way. And I wanted you to see that it didn't matter, to remark that it didn't matter which we chose. All right, so part C is just where we offer the tariff of 1,200 to those who will pay it, and then the tariff of 600 to those who will pay only 600. And then you can maximize profits by getting 3,000 from this group and 6,000 from that group for a total of 9,000. So that's where I said the total ideal profits are 9,000. So that's when you sell, you give each their maximal fixed fee. Okay, so the next one we have to do though, I think I did this here. This is a little bit clearer, I think, if I use my typed answer. Next thing we got to do is we have to come up with profit as a function of price. So remember, what we want to do is the first portion is the fixed fees, an expression for the fixed fee. This is going to be 10 times 3/2 times the quantity 30 minus p squared. All right, so where is all this coming from? The 10 is because I have 10 consumers. I'm going to sell the fixed fee to all 10. These are actually per unit profits. This is the 5 consumers with the low demand. This is price minus marginal cost. This is the demand, right? This is 5 times this is like price minus marginal cost, and then this is quantity. And then here's my per unit profits from my high demanders, my 5 high demanders. Again, price minus marginal cost, and then the quantity that they'll buy at that price. All right, so that's this part right here highlighted as just per unit profits. Let's go back to this part. What do we have over here? Well, let's think about the graph here. So firstly, we've got our 10 units. Now, there's going to be like a 1/2 base times height built in here, right? So I'm going to use my smaller demand, right? You use your smaller demand group to build the expression for the two-part or for the fixed component. So I'm going to have a 30, but not a 30 minus 10. It's going to be a 30 minus P, right? So this side, it's going to be 1/2, not 30 minus 10. It's going to be 30 minus P. And then I'm going to have 90 minus 3P, right, for my quantity, because I don't know that it's going to be 60. It's going to be 90 minus 3P right here. So my expression initially is going to start off as 1/2 30 minus P times 90 minus 3P. Then I factored out a 3. If you factor a 3 out of this, you'll get 3 times the quantity 30 minus P. So that's where that 3 came from right here. This is I factor out that 3. So the 3/2, the 1/2 is from 1/2 base times height. The 3 is from factoring out the 3 out of this 90 and this 3P. That leaves me with a 30 minus P from this side, from the vertical, and a 30 minus P from my quantity, right? And so that's why it's 30 minus P, the quantity squared. Right, so I just do that because then the derivative is a little bit easier. All right, so now I've got this whole thing. Now, how do I take this derivative? I do this cleverly. So firstly, I'm gonna simplify this stuff down. So I'm gonna have 10. This cancels. So this is gonna be 5 times 3 is 15 times the quantity 30 minus P. That whole thing squared. Now I've got this expression. All right, so I haven't done anything yet. That's just cleaning it up. Now I'm gonna take the derivative. 2 times 15 is 30. Then we leave the middle, 30 minus P. Now we take the derivative of the middle. It's gonna be minus 1. Right, so that's just the derivative of the first part. Now what I'm going to do is I'm going to take the derivative over here, and I'm going to say, okay, well, actually, I think I didn't even do it yet. No derivative yet. I just worked on the first part. All right, so let's bring this down. Did a little bit of work here. I moved this minus 1 inside. That allows me to just flip the order of subtraction. Rather than 30 minus P, I make it P minus 30, and that disappears this minus 1. Right? That's all I did there. 30 times the quantity P minus 30. All right, so now over here, now I'm going to take a derivative. I'm going to take the derivative. So this is product rule, right? So I've got this 5 times this stuff times this stuff. And what I did first was I took the derivative. I didn't spell this out. Let me talk through it then. All right, so the derivative of this part is minus 3. So I'm going to get a minus 3 times this stuff. So minus 3 from this portion times this stuff. I'm going to deal with the minus 1 by flipping this subtraction to be, rather than P minus 10 to be 10 minus P, I'm going to deal with the 3 by multiplying by the 5 to give me a 15. That's what I did. Now I'm going to get a 5 times this stuff, 90 minus 3P times a 1, because the derivative of this is just 1. Right? Derivative of this part inside the parentheses is just 1. So I multiply that by this stuff. And that's why it's a 5 times the quantity, 90 minus 3P. I did the same thing over here. I took a minus 6 from the derivative of this portion. That gets multiplied by this stuff. So I'll get a 6 times 5 is a 30. The minus allows me to reverse the order of the subtraction to be 10 minus P. And then I'm going to get a 5 times a 180 minus 6P times the derivative of this stuff, which is just 1. So that's where that came from. And the rest is just algebra. So I'll distribute 30P minus 900 plus 150 minus 15P plus 450 minus 15P plus 300 minus 30P plus 900 minus 30P. And the reason why I do it that way is, like, if you kind of follow what I did, that's like the easiest, kind of most straightforward way. Like, it's the least algebraically intensive way to take that derivative. Yeah, you could FOIL or whatever. Like, you could do that, and then you've got, like, I can't do that. I can do this derivative, what I just did. I can do that in my head. I cannot FOIL and then kind of keep track of all those terms. That's why I always do it this way. All right, so let's see. Then cleaning up, we'll have 900 minus 6P, and then solving, we get a price of 15. With that 15, I can plug that back into this portion to find my tariff, my fixed component profits. So that was 3,375. The per unit profits, right? So I'm just evaluating my per unit profits are 1,125 from the low group and then 2,250 from a high group. This gives me a total profits of 6,750, right? That's not quite our 9,000, but it was sure better than the 6,000 that we got from marginal cost pricing. All right, so next, consider 3 consumers, type A, type B, and type C with different valuations over different versions of the product. So we have high, medium, and low. Now, this is not a bundling question because I tell you the consumers buy at most 1 unit of the good and never buy more than 1 quality. So it's a second-degree price discrimination question. Find the optimal price and profits if you sell only the high-quality version, then the low-quality version, then the medium, and then if you sell all 3. All right, so basically what we're doing is we're going to check and see what happens if we set the various price combinations. So if you set only price, you could set a price of 125 and sell to 1 group, and then your profits are 100. Or you could sell to 2 to your medium and your high and get profits of 90. Or you could set it at the price that the low will buy, and then you sell to all 3 for profits of 60. And you do the same exercise. One place where people made mistakes is, remember, we have a cost of 25 for the high, cost of 15 for the medium, and a cost of 10 for the low. I think I wrote this out here. Yeah, I wrote this out carefully. So basically what we did for A, B, and C, it's basically checking to see how to set the single price. So for high, you're comparing 125 minus 25 times 1 is 100 versus 70 minus 25. This is like the price and the cost. Selling to 2 people is 90. 45 minus 25 selling to 3 people is 60. For medium, it was the price of 65. If I only sell to the high, minus 15 gives me profits of 50. If I sell to the medium and the high, then it was 70. If I sell to the low, to all 3, then it's 60. And then selling the low, I can get 32 different ways. I could sell to 2 or I could sell to all 3. What if I want to sell to all 3? Well, now what you want to do is set the prices to attract only the respective consumer. Set the price of high equal to 105, set the price of medium equal to 45, and the price of low equal to 20. That's exactly backwards for how you actually do it. So the way you do it is you set the low price to ensure that the type C will buy. So set that equal to 20. That's their willingness to pay. Now for part 2, watch out to make sure your type B people are not buying the low. So if the type B people were to buy low, their willingness to pay was 25, the price would be 20, their consumer surplus would be 5. So we have to set the price of the medium at 45 because their willingness to pay was 50. That'd give them the same consumer surplus, and we could plausibly argue that they'd buy the medium type intended for them. Now for part C, or step 3, watch out for type A buying either the low or the medium. If the type A buys the low, their consumer surplus is 10. If the type A buys the medium, their consumer surplus is 20. So we have to set the price of high 20 lower than their maximal willingness to pay at 105 to ensure that they'll plausibly buy the high quality. If we do this, our profits are going to be 105 minus 25, 45 minus 15, 20 minus 10. For 80, 30, 10 is 120. All right, and then the last thing was the network question. So I had in mind Strava. Was that what we did here? Anyway, so what we have to do is we have to build our demand curve, and we have to just it's kind of like either factor or use the quadratic formula. So the relevant quadratic expression is going to be 50 minus 1/4 n. That times n equals 979, right? So we have 200 people in this market uniformly distributed between 1 and 50, right? So the maximal willingness to pay is 50. There's 200 total people. That gives us a demand curve. So we're just drawing like an individual, like an ordinary demand curve that would stretch from 50, or it would be P is equal to 50 minus 1/4 Q. But here our quantities are n's because those are the people in the network. And anyway, but we have to multiply because we have V times N. So following just lecture and following the example, we're going to have the linear portion of the demand curve times the network thing, makes it a quadratic. And then I told us the average cost of producing was $9.79. Anyway, so dropping this into the quadratic formula, we'll have 50 plus or minus 50 squared minus 4 times 1/4 times 979. Don't forget about the 2a, right? It's minus b plus or minus square root of b squared minus 4ac, that whole thing over 2a. So don't forget the 2a. That some people got in trouble doing that. The zeros of the polynomial are 22 and then 178. And so then I want you to compare that. Oh, so there's 3 network sizes: 0, which is stable; 22, not stable. It's going to get either larger or smaller; and then 178, which is stable. Remember, we're going to compare the marginal cost, which is horizontal at 979, versus the marginal benefit, which is coming from my quadratic demand. If the marginal cost is bigger than marginal benefit, we leave. If the marginal benefit's bigger than the cost, we join until we get to the large network. If the marginal cost is larger than marginal benefit, we leave, we come back down. So our stable is 0 and then 178. Our unstable is 22. I asked us to consider 11. Oh, that was smaller than our unstable equilibria, so people are going to leave, and we'll go down to network size of 0. If there's 30 or 60 that's bigger than 22 but not quite to 170, we expect those networks are going to grow, and we'll go up to the larger equilibrium. Okay, so I think that actually concludes the ones that I've got here. And let's see, that's not the puppy. This is the puppy study break that I wanted. Puppy found a hole. Puppy's got some dirt on puppy's nose. Anyway, hope you enjoyed, and I'll see you next time.